We will be starting with Cisco ISE, where we are going to deliver pre-recorded Hindi videos. Not exactly pre-recorded, but they will be like live batches will go simultaneously. English live batch will go. English live batch will go simultaneously on weekends. And once they are done, the same recordings will be done in Hindi and that will be posted in the portal for those who are going to have Hindi batch. And above all, we will also do some recordings for English as well for your convenience. And overall, this entire package, English, Hindi, everything, you will get the entire package in 6,000 plus GST amount in your Cisco ISE course. So that will be our Cisco ISE and it will go for almost duration of this course will be approximately 2 to 3 months, where we'll try and cover maximum topics as much as possible. Okay, so that is our goal for the next 2 to 3 months. And one thing as assurance to you guys that this will be a once in a lifetime kind of a nice course where we will be taking multiple deployments and integration, like integration with different firewalls. Okay, we will be talking about uh, integration with VPN technologies as well, debugging, troubleshooting. So everything will be covered. Along with that, everything that we are going to, take into consideration for this batch, that will be covered in great detail, guys. That will be right from the scratch to pro level. Okay, so this course is going to be one of the very good courses that we have in our domain. So for more details, you can reach out to us on this number as mentioned on screen. And if you want to like download the full curriculum, so you can ping us at this number and you will get the course curriculum, the entire day wise plan, though I'll show you at the end of the session as well what we are going to cover. Okay, that I'll also show it to you at the end of the session. Okay, so now let's start our training. So let's start with Cisco ISE. ISE stands for Identity Service Engine. Now, what is the main purpose of ISE? ISE is basically a triple A server. ISE is basically a triple A server. Now, what do you mean by triple A? Triple A stands for authentication, authorization, and accounting. So these three constituents your triple A feature. So ICE is something which helps us to provide all the three detailed features. Okay, so this is ISE, but what exactly these three does, what exactly authentication, authorization, or accounting does, what they are exactly. So let's understand them with couple of example. So let's take first example of an ATM machine. Okay, ATM machine. Suppose that there is a person. Okay, he goes to ATM. That person has a debit card with him. Okay, this person will go to ATM. He'll insert his debit card into the ATM machine. The moment this card will be inserted into the debit card machine or your ATM machine, it will ask for a PIN. It will ask for a PIN, 4 digit or 6 digit PIN. Once you enter the PIN, you are authenticated. Once you enter the PIN, you proved yourself that you are the correct user, and in the database of the ATM, they have associate your card number, your CVV, and your expiry, okay, with a PIN. The moment you will insert these three things and you match with the PIN number that is installed in the database of this ATM machine, okay, you are authenticated. That means you are the correct user. This is authentication. Now let's talk about authorization. I don't know how many of you remember it or not, but 2016, I think it was year 2016, we witnessed something very different from the India's conventional behavior. In 2016, we witnessed demonetization. If all of us remember that, monetization. During demonetization days, if you remember exactly, we were limited to certain transactions itself. Like for example, a person was not able to take out more than 10,000 rupees a day or 25,000. I don't remember the exact figure, but a person was not allowed to take more than this particular amount from his bank, irrespective of the fact whatever is was his account balance. So what exactly is this 10,000, 25,000? This is your authorization. And I believe even today we have this limit that we can't take out more than 50,000 rupees per day from a basic ATM machine. Uh, Unless and until you are not a exceptional or a special customer and you have a special card, you can't take out more than 50,000 rupees per day from an ATM machine using your ATM card. So this is your authorization. You are not authorized to do anything beyond this. Once you take out this 50,000 rupees, you get something, SMS in your phone or email email that states the transaction you have done. And after transaction, the updated status of your account. So what is this exactly? This is basically accounting. So this is your authorization, authentication, and accounting in terms of layman language. Let me give you one more example for AAA. Okay, let's take an example of Wi-Fi in public places. Wi-Fi Public places. When you go to a public place, let's suppose airport or a railway station or many other public places like libraries, etc., etc., etc. You get this facility of using public or free Wi-Fi, right? How do you connect to that Wi-Fi? Step number one. These are mostly open Wi-Fis. You don't, in most of the cases, you don't require any password to connect to them. These are open Wi-Fis. So the moment you connect to that open Wi-Fi, it redirects you to a browser, and in the browser, it asks for your phone number. After entering your phone number, you get your OTP. You get the OTP. Once you enter the OTP, you are authenticated. This is your authentication. Okay. Step number two. Once you are connected to these open Wi-Fi's, I have seen, like, I recently traveled from one airport to another airport to when I was traveling to my hometown. So I observed that this open Wi-Fi is valid for only 30 minutes. I don't know if someone gets full time or the free access to 24/7 Wi-Fi, but the same thing didn't happen with me. I got it for only 30 minutes. Very less, but what exactly this 30 minutes is? This 30 minutes is my authorization. After 30 minutes, I'm not authorized to use the same Wi-Fi anymore. That means I have been authenticated and I'm authorized to use the Wi-Fi after being authenticated for 30 minutes. So this is my authorization. Step number three. So the moment I was doing using their Wi-Fi, after every 10 minutes, I was getting this message that I have utilized these many minutes and I've been left with 20 more minutes, like this. So I was keep getting the SMS from that public Wi-Fi provider. So once after 30 minutes, I got the message that I'm done with the free access of the Wi-Fi. So what is this? This is your accounting. That is how your AAA works. Okay. Au- Authentication, authorization, and accounting. Now, what do what are the two most basic requirements to use AAA? Before like going ahead with the AAA or ICE, we need to understand what are the two most basic requirements that I need to play with AAA. What do you think? Not this one. Two basic requirements of AAA. Two basic requirements that we do using AAA. First is the network access. and second is your device administration. Now, what do you mean by network access and what is device administration? Though who the guys who are working in production environment, they are very well aware about these two terms, but still, let me give you a small brief that what is network access. Network access implies that I have a user, okay? This is my user, and this user connected to a router. For example, us only, what do we do? This is my laptop, my current laptop. It's connected to my Wi-Fi modem, right? It is connected to my Wi-Fi modem, and then Wi-Fi modem is connected to the area switch, and this area switch is connected to some area router, and further it is connected to ISP. Right. So the moment my laptop has to connect with Wi-Fi modem or your access pointer, whatever is there, or directly with your access switch, directly it has to connect with your access switch, it has to verify it himself first, right? It has to verify himself first. How can he verify? He needs to connect to this Wi-Fi by putting some passwords, right? You need to connect to a Wi-Fi, you need to put a password, you need to authenticate yourself. After authenticating yourself, now you are free to access the internet. Once this is done, you can freely access the internet, right? This type of communication is known as network access when you are authenticating XYZ device to access the internet. Okay, or I can say when you are authenticating one device to access other device, because ultimately we are accessing other devices only over internet. For example, I'm saying I want to access facebook.com, right? So when you are doing facebook.com, you are accessing the Facebook servers that are kept somewhere over the internet. You are taking their https access, right? So what is this type of access? This type of access is known as network access when you are authenticating to one device so that you can communicate with the rest. Okay, so this is your network access. Okay, let's talk about device administration. As the name suggests, for device administration is basically accessing a particular device only. Please understand the difference between the two, network access and device administration. In the first case of the network access, I was just authenticating myself. You were authenticating yourself to a device so that he can allow you to communication from himself towards the internet. But in this case, I am authenticating to access this device. I want to access this device. I want to do some changes on the device. So accessing a particular device so that you can manage the configurations over it. Configurations over the device is basically your device administration. So this is your network access and device administration, and these are the two basic things for which we take the help of Cisco ISE. Okay, now let's move on to some more advanced topics. Okay. I hope you got the basic idea that what is AAA, what do you mean by AAA, why do I need AAA for network access and device administration. Okay. So now let's move to ICE. What does ICE do exactly? What ICE provides to us? So as the name suggests, identity service engine. Okay. As the name suggests, identity service engine. It supports AAA features, not only AAA features, but also ICE provides policy based network access for policy based network access for advanced sections. Okay, how does how to create this policy? Definitely we'll talk about in the upcoming sessions, but this is the main feature of the ICE, that it is used for the policy based network access. So but what exactly do you understand by the network access? Policy based network access, policy based network access is like, for example, this is a let's say this is your switch. Okay, behind your switch you have a access network, and one of the access network has VLAN, let's say 50. So I have a user ABC that is connected over this VLAN, and I have another user XYZ that is connected over same VLAN. Okay, that is connected over same VLAN. I want ABC user to access internet. Okay, but I don't want XYZ to access internet. I want XYZ not to access internet, as well as I want XYZ to access, let's say he's from HR department. I only want him to access my financial servers. So these type of management related things which involves your advanced actions that can be managed with the help of Cisco ICE. Apart from these features, it helps to secure access network as well. Same thing. If we are involving policy in anything, it provides us the extra sense of security, because if we can manage policies, like with the help of policies, we are saying this cannot access network, or user from HR department should not be able to access the CMDB servers. So like that. So this type of policy based network access provides you the extra sense of security in your environment. ICE can basically authenticate anything. ICE can authenticate anything. And that too on very granular level. Even the advanced highest level of advanced sections you can also take on the basis of or with the help of ICE. What I'm trying to say, granular level, what type of operating system I'm using, what is my antivirus, whether I have installed the antivirus or not, what is my hardware. So these type of actions. So for example, I have a user, okay, I have allowed this user, once it is authenticated, it can go out. Okay. It is kept on VLAN, let's say 100. But this policy which was allowing that user to go out after authenticating himself, it is also stating that user should have minimum Windows 11. But same thing is not there with my user. Let's suppose that policy is allowing my user. Everything is there. It's the correct authentication, correct username, correct password. All the rules are there to allow the user to access the network. But user is not matching. User has Windows 10 and my policy is saying it should be Windows 11. So my ICE will not allow the user to go out. No, it will not allow the user. It will not authenticate the user. ICE is one of those network devices which takes lot of network information into picture. And generally, in you must have observed this thing with many other network devices that though they take a lot of information in their packets, whenever their internal packet flow happens, they take a lot of unnecessary irrelevant information that they don't even require from the user and they make absolutely no use of it. But ICE is not like those network devices. ICE is one of those rare devices which takes all those network related information, user related information from the user, and with that information you can do best optimization of your policy and you can secure your access network as much as you can. Okay, the only thing that you need to make sure with the ICE, you need to make sure all the requirements and compute should be met. We'll talk more about compute as well for Cisco ICE. So it should be met. Otherwise, your ICE will not work the way it is supposed to. ICE is a very, very heavy machine. ICE is not like a Cisco router or a switch or a normal firewall. ICE is one of the heaviest devices in the entire networking or security domain, guys. It's at par with FTD and checkpoint, I would say. Okay, how basic architecture of ICE looks like. Basic architecture of Cisco ICE. Before going with Cisco ICE, basic architecture, why do I need ICE? 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 See, ICE is a kind of a AAA server, right? If you have logged in into a Cisco router, let's take an example of Cisco router. Okay, once you log into a Cisco router, it has AAA feature inbuilt into it. You can use local AAA database. Okay, even Cisco ASA as well. Okay, where you can create local database and you can use that local database for your network functionality. Okay, let's take an example of Palo Alto or any other firewall as well. For them as well, for device administration, you can create a local database. Create local database or local user, and you can associate that user or that admin with an admin role, right? You can associate that with an admin role. So once you do that, that admin role will take into consideration and that will be like your authorization, that what that admin is authorized to do. Okay, even we can create basic username through line console as well. Line console, and then you give the password something something something. So that can also be used to log in into the for the device administration of Cisco related products. And same thing, this local user admin and admin roles you can do not only with Palo Alto but with 48 as well as Checkpoint or any of the networking device we have into our environment. Then why do I need ICE? Why do I need a remote AAA server? See, with ICE, why I'm increasing my total size of the data center? Why? Because if I can do this entire thing on my device locally, why do I need a separate AAA server? Because if I will install a separate AAA server, okay, so though we'll discuss this packet flow in great detail, but some messages will go and some messages will come, and unnecessarily this will increase your bandwidth utilization, right? So why do I need this? Why do I need a remote repair server? So the answer is very simple. Consider the example of a firewall. Okay, this is router, edge router connected to ISP. Behind your edge router, you have an external firewall. Okay, so why this firewall? When I'm, let's suppose this firewalls, this interface, I'm configuring routing protocols. Let's suppose routing protocols are configured. Okay, let's suppose BGP, I'm running BGP. Let's suppose, though it's not practically possible, definitely over here OSPF will be running, and even if OSPF will be running, still. Okay, so I can perform routing on my firewall. That is the one of the purposes of the firewall. What is the main purpose of my external firewall? Main purpose of the external firewall is to filter out the external traffic that is coming into my environment. Okay, it will filter out all those unnecessary traffic, malwares. It will filter out the unnecessary URL, whether it's going out, even something is going out towards the internet as well. It is used for your SSL decryption, antivirus, sandboxing, right? All those advanced features. This is the main job of my external firewall. And apart from that, basic security provide. Whatever you need basic security using the policies, that is also it is providing. And in most of the data centers you will see external firewall has huge chunk of NAT rules, because this is the firewall that is natting your traffic and letting your traffic go out. Okay, apart from this, let's suppose I'm also managing local user database on my firewall as well. Now if I'm using all the three features, definitely if I'm using routing protocol, I'm talking about the dynamic routing protocol over here, whether it's BGP or OSPF, definitely my external firewall will build a very big routing table as well. In a production environment, size of the routing table is huge. It takes lot of memory. Okay, it's very huge. If it's BGP, it's more than something that we can manage. So is this the primary thing that my firewall should do? My firewall's primary thing is this one. These are the additional features. See, routing, local database, or whatever these additional features are, they will be just like additional features for me. They are not the main features of the firewall. If my firewall, if this single firewall of mine, okay, let's suppose it is PA 3220. Okay, if I am not deploying any ICE, or I'm not migrating my routing to a particular router, I'm using my external firewall itself. Let's forget about the security related complications for a moment. If I'm using all these using a single box itself, what will happen to that single box? That single box memory utilization will go up. If all the features are being used by single box, memory utilization will go up. If memory utilization will go up, what will happen? Data plane and management DP CPU and MP CPU, they will also go up. If they'll go up, what will happen? You will have latency in your environment. When I'm talking about ICE, right? If I have integrated ICE, packet will go, packet will be back. It's like a flow, one time flow, right? After that, it will not occupy the resources of firewall. But if I am creating something locally, they will remain over my firewall memories till the time they are not removed. So like this, I'm increasing the overall utilization of my firewall or any of the device, whichever I'm using, whether it's router or a switch or anything. So that is the reason for any additional feature like database management, we install a separate device for remote management of our all the users. Okay. And that separate device is known as Cisco ISE in our case. Okay. So this is your Cisco ISE. That is why it came into picture, and it is one of the heaviest machines that are known to networking domain. One of the heaviest machine. I'll give you a small example. I I will use ISE 3.2. I will use 3.2 for our sessions. This will be used by me for our sessions. This image size itself is 13 GBs. Once you will enroll for the course, I will definitely provide this 13 GBs image to you. Okay, so that you can install it in your environment. But even in order to install it in your environment, you need good amount of compute, very good compute. If you don't have a good compute with you, forget about it. Okay. Okay. Now let's talk about the basic architecture of ICE. Okay. So what is the basic architecture? So I will be, discussing the .1x. What is .1x? Definitely we'll discuss in the upcoming session, but I will just giving you a brief that how exactly it looks like. Okay. There is the access device. Okay. This is your access device. Then after your access device, it could be anything. It could be my mobile. It could be my printer. It could be anything. Okay. These access devices are generally connected to your NAS. What is NAS? NAS, Network Access Servers. Okay. Switch. Generally, it's going to be a layer 2 device because you first interact with the layer 2 device in your environment. Okay. For network access and for device administration, you directly interact with your servers. So that will also we'll discuss. Let's say it's a switch or maybe anything like a router, whatever it is for your, okay, for your environment. And ultimately, ultimately, we have your Cisco ISE. Okay. This part, this access devices that communicates with your network devices or your NAS, network access servers. Okay. This part, the access devices, they are known as supplicants. This part over here is known as authenticator. This part over here is known as authentication server. It could be anything. We are taking ICE, but it could be anything, guys. Any other authentication server as well, if you have put into your environment. Okay, so request will go to this switch, this your layer 2 devices. They will send the request for the authorization to the ICE, and they will ask the ICE to provide the username and password, or to check that this is the username and password we have got. What is your point of view on this? The entire packet flow we'll discuss in Radius, how the flow of messages happens. So once that is approved, I sends them a message that it's authenticated and like that. So this entire thing in the middle is known as authenticator, which sends the authentication request to the server. Okay, this entire communication over here, EAP is responsible for this extensible authentication protocol. Okay, we'll discuss all the messages of EAP as well. And over here, it is radius. This radius, TACAX, all these things we will discuss. EAP and radius. So these are the two protocols that we have. So from supplicant to authenticator, it's EAP that is responsible. From authenticator to authentication server, it is radius. Now, there should be a concern for you guys that in my environment, let's suppose that I have already installed AD servers, LDAP servers are already there, and my devices are directly communicating with those AD servers for the purpose of network and device administration access. No problem with that. Even if you have that, you can install ICE in your environment and you can integrate that ICE with that AD stack. Whatever you have, you can integrate it with your AD stack. Once they are integrated, then you can take the requests from your AD stack, like whatever the database that AD has, you can share it with the ICE, and ICE can take the advanced level policy based action on that database of the AD. So this is the advantage of ICE as well. It can integrate in your existing environment as well and can provide you a more secure network access as well. Okay. Okay. Okay, so that is how your basic architecture of ICE looks like. So ICE basically provides you policy based access. That is the major advantage of this device. And this policy can be applied in multiple ways. Okay, this policy can be applied on VLAN level as well. Policy can be applied on VLAN level. Okay, that means I am asking a particular VLAN to access the way I have configured the wall policy. You can also use micro segmentation. These are generally a basic VLAN level ACLs I'm talking about. Okay, that you can configure in your ICE and you can further push it towards your centralized switch. Micro segmentation. So micro segmentation is also supported in Cisco ISE. Okay, that means we can apply ACLs on the basis of port numbers rather than centralized VLANs. When we will discuss the policy based flow, we'll also discuss micro segmentation. It's a topic in itself. Okay, I'll just give you a small brief over here. Okay, this is a switch. Okay, I have a centralized VLAN policy over here over the switch that is pushed to the switch from my Cisco ISE. But I don't want to use that centralized VLAN policy. I even more want more granular level access. That I don't want certain VLAN users to directly access something. I want more granularity over the VLAN users that are associated with this VLAN 100. Okay, over this access pointer, then we have, let's say, some 200 users. I want more granularity for them. Okay, I want to configure more advanced actions for them. So that is also possible in Cisco ISE, and this type of concept is known as micro segmentation. So you can take the base decision making on the basis of VLANs. You can take the decision on the basis of users that are associated with the VLANs. Most important feature of Cisco ISE, last, very important and one of my favorite, things that ISE can perform, tag based access. So Cisco ISE can allocate tags to the users, tags to the users or devices. Okay, tags to the users or devices. Okay, and based on these tags, and based on these tags, it can take advanced actions. For example, like I'm saying, tag one user can communicate with tag two user, or I don't want tag two user to communicate, or to access internet. You don't want that. So like that also you can do. With this tag based thing, you are making your environment independent of IPs. IPs can change. You can go from one geographical location to another geographical location. So if a particular user or a device is associated with a tag, his policies will remain as it is over my Cisco ISE. And this feature of tag based access is known as TrustSec. I got a lot of queries that will we cover TrustSec or not. Yes, we will definitely cover TrustSec, and I'll show you in great detail. Though this is just a brief overview that how ICE applies the policies. We will discuss tag-based access and even the other form of policies that are possible with Cisco ICE in detail in the upcoming sessions. Okay. Okay. So this is about your Cisco ICE. Okay. There is our watermark. Here is my watermark. Okay. Sorry. Okay. So we discussed ICE, we discussed the requirements, we discussed basic architecture, we discussed how the basic, policies looks like. We discussed what is AAA. Now let's talk about the features of ICE, major features of ICE that we have. First feature is profiling itself. Okay. First feature is profiling itself. That is what I'm talking about since now, that how Cisco ISE takes some information into consideration, like your OS, like antivirus, like XYZ, and take the decision making accordingly. So this type of thing is known as profiling, guys. Second major feature for ISE is posturing. We are going to have 1 to 2 dedicated sessions for all these features. Okay. Similarly, posturing is basically for compliance check. Basically for compliance. Okay. Again, we'll discuss posturing in separate session for posturing. Then you have BYOD, bring your own device. So ICE can also accommodate your own device if you want to bring your own device into your company's environment. So how to establish authentication or how to provide the authentication or the important access to device, that also can be done over this. Okay. Fourth is your guest authentication. At the very beginning of this session, as I told you, that ICE provides you this feature where you can access your public, public servers, public wi-fi's. So that is a kind of guest authentication, like a new user is coming into your environment and he wants access for certain amount of time, or access of certain devices. So you can authenticate that guest and can accommodate him and can provide him the certain accesses. So that also can be managed with the help of ICE. Then you have your MFA as well, multi-factor authentication. You can also configure MFA as well in Cisco ISE. So this is your Cisco ISE, guys. So let's talk about the major hardware versions and software versions of Cisco ISE. Okay, major hardware versions of Cisco ISE. Okay, ISE has, you can install ISE in your separate chassis, or you can install ISE in your own environment with the specified compute that Cisco TAC will recommend you. Okay, so for example, basically ICE, if I talk about its hardware versions are known as SNS, basically SNS, which stands for Secure Network Servers. They're very, very heavy, guys. They're very, very heavy, and depending upon your requirement, you can have multiple SNS servers. Okay. Generally, hardware versions of ICE are all the SNS servers. Their versions are 3x15, 3x55, 3x95. Okay, where 3x15 is your Small deployment eyes, that is if you have very small requirement. Okay. 3x55, these all deployment modes. I'll also tell about the deployment modes as well in the upcoming sessions. 3x55 is like your for your medium deployment requirement. And then you have 3x95 servers. They are for your large scale deployments. And X has only three values, 5, 6, 7. Okay, that means 3, 5, 1, 5, 3, 5, 5, 5, 3, 5, 9, 5, 3, 6, 1, 5, 3, 6, 5, 5, 3, 6, 9, 5, 3, 7, 1, 5, 3, 7, 5, 5, and 3795. So these three are very small scale, small deployment servers. Okay. And these are your medium scale deployment servers, and these are your large scale deployment servers. So you can like purchase these SNS hardwares. Okay. SNS hardwares version, these 9 versions from Cisco. Otherwise, if you feel like you have the specific compute for your environment, you can host certain things into your environment by itself. So Cisco gives you option of VM as well. It gives you an option of VM as well. You can take the VM and you can install that VM in your environment. Okay, but you need to make sure you have the proper resources for that. Okay, and if I talk about software versions of ICE, so they are like this: 1.0, 1.4. They were the older software versions for ICE. Then came series of 2, 2.0, 2.1, 2.2, 2.3, 2.4, 2.6, 2.7. Okay. And now the recent series that is going on. Okay. That is the most recent. That is most of the recommended by Cisco tag as well. That is 3.0, 3.1, 3.2, and latest 3.3. This is the latest that is going on in the market. Okay. And Cisco tag recommends Cisco tag recommends to go with 3.2. Why? Because Cisco follows this criteria of n minus 1. What is n minus 1? If let's suppose 3.3 is into the market right now, so Cisco wants you to follow 3 n minus 1. That means 1 minus to the addition that is available in the market. So if current market addition that is available in with us is 3.3, so Cisco wants you to go with 3.2. They don't want you to go with 3.3 yet. Why? Because that is recently, that came recently, and Cisco wants to do some R&D of that version. Because if something comes new into the market, its R&D is not done properly, though they have done it in their end, but something that should be tested into the production environment is different from what something is done in the lab. So 3.3 is still being tested into the production environments. And same thing goes with every device. If you go to every device, it's not confined to Cisco's stack recommendation, or not only confined to Cisco's stack recommendation, but it goes with any device that is available in the market. For example, Palo Alto, FortiGate, Cisco's other devices, Checkpoint. They always want you to go with N minus one. That is, don't go with the recommended, or don't go with the current version that is available. Go with what is recommended minus one from our side. Okay, so just give me a moment. Let me see if I can share it with you. Okay, let me share my screen. Okay, I hope my screen is visible to all of you. So over here, you can see that this is the software.cisco.com. Okay, you can go to software.cisco.com. I selected 3.3.3. Okay, this is the current version that is available in the market, latest version. But you can see over here that star marked is 3.2.0, because this is what Cisco recommends you to go for. Okay, Cisco wants you to install or to go with 3.2.0 in your environment. Cisco doesn't want you to go with 3.3.0 directly. Okay. Okay. And most importantly, I think 2.6 is going out of support very soon. Uh, I think 2.4 has already been end of support. Okay. Till 2.4 it is end of support. You can like check it online once. Let me see. uh, Cisco ISE 2.4 end of support. Yeah, you can do this. Let me scroll down. 2.6, let's see. 2.4. Okay, yeah, you can see software maintenance for 2.4 ends on 26 December 2021. Okay, ICE pick 2.4 will reach end of support 26 December 2022. So it got end of support last year itself. And after 2.4, we have 2.6. So 2.6 software maintenance release ends on 31st January. Okay. And its support will end on 31st January 2024. So post 2024, like after 1 month, even for 2.6, support will finish. So if somebody is at 2.6 in their environment, I would highly recommend you guys to migrate to 2.7 as soon as you can, because otherwise if you face any issues on 2.6, Cisco TAC will not help you. After 31st January, they will not help you if you face any issues. Though on special request, like if you like ask specifically for the support for upgrade, okay, support for upgrade for out of support or for end of support versions, they do that. Like for example, my current Cisco ICE is running 2.2. Okay, and I want to go to 3.2. So I can like patch a case with Cisco tag and I can ask for their help. So they will definitely give me a time slot and accordingly I can plan my activity. But always make sure if you are planning an upgrade for Cisco tag, take a downtime. That is very important. Take a downtime for at least 12 hours. At least 12 hours. Okay, because you never know what kind of issue it can come up with. uh, a few days back I upgraded my eyes from in my environment itself from 2.7 to 3.2. It took 8 hours for single device to upgrade. Okay, and after 8 hours we were stuck with a bug, and uh, I was on call with Cisco tag for 3 consecutive days because of that bug. Ultimately, we did some changes in the environment and fortunately it got resolved. But at the end of the day, it took hell lot of time. You never know. So these are the products you never know how much they take. Okay, so make sure if you are using any of the versions that are going end of support, or you can just go back after this, after attending this session, you can go into your environment and you can check what OS your ICE is running. You can check and accordingly you can plan for update. Okay, okay, let me show you the OS. Uh, you can simply go to Google. For example, I want to install 3.2 VM image in my environment. I don't want to go with uh, anything other than 3.2. Okay, and I don't want to purchase hardware for 3.2. So I can go and I can do this 3.2 installation guide. Okay, just go to the 3.2 installation guide. Okay, network deployments in Cisco ISE, Cisco secured network service and virtual machine requirements. Okay, go over this, scroll little down. You can see Cisco SNS 3715, 3755, 3795. Okay, these are small, medium, and large deployments. Okay, you can see hardware specification. If you are going with 3.2 on 3715, it should be UCS C220M6 chassis. This should be the processor name. It needs to have minimum of 12 CPU cores, 32 GBs RAM, 600 GBs of hard disk, and 800 GBs of SSD. And like this, you can see for 3755, 3795. Okay, if I'll scroll further down, these are the virtual machines available or .ova files available for Cisco ISE. You can install them, and after installing them you need to make sure that what is the type of deployment I want. Okay, all these deployment modes we will definitely discuss. So what type of deployment I want, depending upon the type of my deployment, I can allocate the number of CPU. I'm talking about cores over here, number of CPU cores, RAM, and the RAM. This is the reservation of the RAM. Definitely, you have to reserve this much of minimum RAM for extra small, small, medium, and large, depending upon what deployment your TDA or your TD is recommending you. These are the virtual requirements. Okay, clock speed 2 gigahertz. CPU core should be minimum of 4 CPU cores. Okay, if it is evaluation is a basic product, basic Cisco ISE. Okay, otherwise if it's 3500 series, these much core should be there, CPU cores. Okay, for large 16, so 3600 series, like this it should go. Memory, if it's evaluation, 16 GB. For production environment, evaluation is when you install ICE, you get the evaluation license for 90 days. In that 90-day period you can test the features of ICE, but when it has to go into the production environment you need to make some changes with the compute. Okay, so if let's say when you were doing the testing in your environment, your compute was 16 GBs. Now it will go to 32 GBs. Okay, if it's going into the production, if it's extra small, small, or medium, or large. So like that, you need to make sure. Okay, so you can go through this link. I'll definitely attach this link along with this session so that you can go through this. Otherwise, even if you don't have this link, you can simply type it over the Google 3.2 installation guide, and you can go for the installation guide and you can see for the installation guide for yourself. Okay, hard disk 300 GBs, Similarly, 300 GBs to 2.4 TB of disk storage it requires. So lot of space, definitely won't deny that. Okay. So you need to verify all these things before installing any VM image in a specific computer.